Hey everyone, today we are diving into another super cool programming topic called dynamic programming. It has two approaches, one is top down approach and another one is bottom up approach. We'll see this in soon and let me explain what is dynamic and what are all the importance and how it works, everything. The dynamic programming, I can call it the art of laziness. Why? Because DP is all about solving problems the smart way instead of doing the same work over and over again. Right? In DP, we don't just solve problems, we remember our solution. So we don't waste time solving the same thing twice, like having a cheat sheet for life. Just imagine. The dynamic programming is very efficient, fast, and totally awesome. A totally optimal solution. It is one of the programming technique to solve problems, right? By the end of the video, you'll know what the dynamic programming is, the difference between top-down approach and bottom-up approach, and you'll solve a problem step by step like a pro. Before we dive in, let me warn you, DPs might sound intimidating, right? But trust me, it's easier than trying to figure out something. DP is a technique to solve problems by breaking them into overlapping subproblems, solving each subproblem only once. Note this point. It's solving each subproblem only once. That's why it's very optimal and storing the result for reuse. Okay, the top down approach one is and another one is bottom up approach. We're going to see today only bottom up approach. We'll see top down approach in future. Let me explain you only in theoretical both, but in practical we'll see today only bottom up approach. Okay, what is top down approach? Recursion with memoization. Recursion, let me explain about recursion. The theoretical general way of explanation of recursion is a programming technique where a function call itself to solve a smaller version of same problem. This continue until it reach a base case. From the top, it will solve like a parent and its child. It become parent again and it solve to the child. Okay, this is what the top down approach will work. With the memoization of beneficial, um, when we are calculating, generally we calculate top down approach from the top to left and right, like in order way. Okay, in left, when we are solve calculated this child and this child to get this parent parent solution, and again the parent is same, like it will 4 Fibonacci of for example, take it as Fibonacci of 4, and again here also a Fibonacci of 4. Okay, we are already calculated here the function call here and calculated here, the we know fourth the Fibonacci of problem is something. But when it will come here also a Fibonacci of 4, this function call again here. So it takes too much of time, right? By using memoization, by using a dictionary or array table to store this Fibonacci of 4, once it calculated, when it meets again the same, it will take from the table and utilize it whenever it need. That's why the memoization is work. It will reduce the time complexity. Okay, we'll see this in practically in future, don't worry. What is bottom up approach? Bottom up approach is tabulation. It's nothing but build a solution iteratively from the smallest subproblem to the main problem. Use table to store results step by step. Just create a dynamic table, just array, just simply dynamic array. If we need to find out Fibonacci of 20th value, like 0th value is 0, First value is 1. Adding this 0 plus 1, second value is 1. Third value is 1 plus 1, 2. Fourth value is adding second value plus third value is fourth value become third. Until it's 20 we have to find out and store in this dynamic array. What will you do at this time? At this particular time, what will you do? We have to calculate this to form this, right? We'll see in this. Okay, we'll see in this tree for even more better understanding. For the top-down approach, it will start from here, and once we calculated Fibonacci of 3 and Fibonacci of 4, we will get the answer of Fibonacci of 5. This is how this calculate from the top-down approach, like depth first search. We'll see in future about this, but we are going to cover now bottom-up approach, how it works from the bottom to the top. Okay, tabulation. I told you guys already that 0th index has 0. Start from 0. Take it as defaultly. First index has 1 and second index has 1. 0 plus 1, 1. Third index has 1 plus 1 previous, and add this and this, you will get third index of the Fibonacci is 2, and fourth it will 2 plus 1, 3. I hope you guys got it. This is how the Fibonacci series continues until 20. Just if example take 20, we have to find out and store on the dynamic array until 20th index. Okay, just if you are calculating 0th plus first Fibonacci, 0th plus first Fibonacci, we will get second Fibonacci of answer, right? Once if we already again the Fibonacci of 2 is occur, we already stored Fibonacci of second value is 1, we already stored, right? If it come, we can easily get from this and utilize this value that we had already stored, and we can show them. First example, first time we have to calculate this. We have to iterate from until n, right? After that, until we are, just imagine we are calculated until the 20, we have an answer until 20. Okay, until the 20th index we had every value of the Fibonacci. Okay, now we want n of 5, fifth index of the Fibonacci value we want. Okay, until 20 we iterated, the time complexity took O of n. Okay, now we want n of 5, fifth index of Fibonacci value. We have to take them and show. What will you do? Just directly access, because we had already until the 20th index we had every answers, right? Enough fifth index has some value, so we can directly access that index and take that and show that. The time complexity took of 1, because we are directly accessing the index, right? I'll show you in programming for better understanding. It is how the Fibonacci forms number series. Okay, just take n equal to 5 for now. So okay, n equal to 20. Just form the dynamic array. TP equal to form. I'll take 0 into until 20, 20th index n plus 1. Okay, fine. Just take dp of 0th index and first index, second index as a defaultly. dp of 0 I'll take 1, dp of 1 I'll take also 1, because 1 plus 1. I'll just skip the 0 for just skip the 0. We'll start from 1. Sorry, dp of, okay, dp of second index is 1 plus 1, 2, right? We are going to iterate here from range from 3 to n plus 1. Okay, dp of I, guys, here dp of I is dp of 3. Okay, first iteration dp of 3 equal to dp of I minus 2. What I minus 2? I minus 2, sorry, I minus 1. I minus 1, what is I minus 1? 3 minus 1. It's dp of 2 second index. Okay, plus dp of I minus 1. I minus 1, 3 minus 1, sorry, I minus 2. I minus 2, dp of 1 equal to 1. 2 plus 1, 3. dp of 3 equal to 3. dp of 3 equal to 3. Just print and you'll get better understanding. Print dp. Until 20 we have an answer. Okay, this time complexity took peak O of n. Okay, now we need only 5. Fifth, just access the directly, will get 8. So this complexity, this time complexity is O of 1. I hope you guys got it.